Hello, this is Sam again. Wanted to summarize kind of the things we talked about in the discussion for week one. The discussions have been very good, but we want to kind of summarize that. Raised a lot of questions, and I'm hoping we can kind of address those. First of all, sounds like practically everybody would rather take the class in the classroom um, instead of online. I would rather teach it in the classroom. I've had very good luck with this course in the classroom. People really do uh, have some really good discussions and really develop some good mathematical understanding um, in the classroom setting where I've taught this class before. And I was skeptical about being able to do that in the online format. So far, we've had some good discussions, but like I say, it's good after the discussions to kind of summarize that. That's the purpose of this video. Um, Main question seemed to be about the decimals, kind of dividing by decimals, or decimal division, basically. So I want to start with that. What I want to work on today is um, 10 divided by 7. As you can probably see looking at the screen. Uh, so I have 10 squares, and I want to divide them between 7 people. A lot of people said they really like art. You're kind of seeing the extent of my art capabilities right now. So I, this is about the best I can do in terms of art. But anyway, you can see the people. Um, Normally, I would divide up cookies. Cookies are a lot more interesting. But you'll see in a moment why I needed to divide up squares. Um, so we're dividing squares among the 7 people. Um, and you probably remember from math class, uh, you are taking 10 things, you're dividing them among 7 people, and everybody has gotten 1 square, and you can see we've taken out 7, there are 3 left over. Um, and initially, when you study math, you are told to say that you have a remainder of 3. And there's some applications for that in math, but not a lot. Mostly to do with code breaking and things like that. You really don't use the remainder. What we say is then that we would have uh, 3/7. So we could divide each of those squares into 7 pieces and give each person 3 of those pieces, or 3/7. Um, that's an exact solution. Fractions, though, really, even though they're exact and mathematically they're very handy, when you start to use math, you really don't use fractions that much. Um, One of the things I like to do in this class is start off by talking about Alan Turing, who basically came up with the idea of the computer, the digital computer. Um, I show a video where Steve Wozniak, one of the people who started Apple Computers, says Alan Turing basically came up with everything that computers do today. So he really was uh, one of the most important people in the 20th century. Um, but uh, Important thing about computers, though, computers can't really do fractions. They're not set up to do fractions. Um, I also like to talk about Carolyn Johnson. Katherine Johnson, I'm sorry. She was a computer for NASA. In the 1960s, computers were a lot more expensive. You could actually afford to pay someone to do calculations. Uh, she could have done fractions because she was doing things by hand, but it's a lot better with science. It's a lot better to use decimals because fractions actually get confusing. With science, you're making measurements which are not exact. Um, so there is some rounding inherent in the mathematical or in the scientific instruments that you're using to measure things. So you really don't need something that's mathematically exact. Um, and then, in addition, the slide rules and adding machines that came before the computers. In the 1960s, I remember my parents had an adding machine. You push all the buttons and you pull a lever. Um, those are all capable of doing decimals, but they're not really capable of doing fractions. Uh, some calculators now and some computer programs are capable of doing fractions, but it takes a lot of programming skill to write those programs. Computers are really set up to use decimals. So we want to not even do the fraction. We want to do this as a decimal. And the idea with decimals is that our next step is going to be to break each one of these up into 10 pieces. So we're going to break them up into tenths and distribute the tenths. So I cut each one of my squares into 10 pieces. And now I can distribute those 10 pieces. And what that ends up looking like on our division, we're going to put a decimal point here. We're going to put a decimal point here. Actually, I'm going to put the decimal point here and say I originally had 10 and 0 tenths. So now I can say I don't have 3 squares anymore. I have 30 tenths of a square. And I know that I can multiply 4 times 7 and get 28. I'm going to be left with 2 tenths. So that kind of helps me out here because I can just take 4 at a time. thought that would help me out. Everybody gets 4, and we have 2 left over. So the problem then becomes, what do we do with the 2 pieces? Well, we now break them up into hundredths. So I now have to say, let's pretend we had 0 tenths, not pretend, we had 0 tenths and 0 hundredths. So now my 2 tenths becomes 20 hundredths, which you see over there. And I'm going to say, well, how many can I put in each one? Well, 2. It gives me 14, and I have 4 left over. So if I can put 2 on everything, everybody gets 2 hundredths. And I have 6 left over. I wasn't paying attention. And if I distribute those 6, then I can say that everybody but one person gets 1 whole square, 4 tenths of a square, and 3 hundredths of a square. So I can say 10 divided by 7. And we use the fractions for um, division. If you remember, originally I talked about the 3 squares being divided into 7 pieces, or 3/7. That was actually 3 squares divided between 7 people. Each person would get 3/7. So a fraction is actually a division problem. And if you put a fraction in your calculator, you can actually do it using division. But anyway, I say 10 divided by 7 equals 1.43. And I've rounded off to the hundredths place. That was another question that came up. Um, what is something that is, what does it mean to round to the tenths place, or the hundredths place? So the first one after the decimal place is the tenths place, and then the second one is the hundredths place. And as we rounding basically talks about, is it closer to 1.43 or closer to 1.42? Most of the people are going to get 1.43 if I continue to divide those out. So if I can't break the pieces up anymore because they're too small, but if I could cut those in tenths, cut each one of the hundredths into tenths, I would get thousandths. I could continue distributing them. But whatever answer I would get, it would be closer to 1.43 than 1.42. So hopefully you can use that demonstration to make a little more sense out of the decimal division. Like I say, it's not exact, but typically we're using math in things that don't need to be exact. So that's kind of the idea behind decimals. And it really does allow us to use calculation devices. Another thing we kind of talked about this week was the order of operations. Some people have heard PEMDAS. I never heard PEMDAS when I was in school. They just said, please excuse my dear Aunt Sally. The idea behind the question that I had asked, you were buying 3 different things at the grocery store. You had to multiply the unit prices times the number that you buy before you add them up. The order of operations is really just a convention. I don't want you to put any more meaning into it than that. There are a lot of times in math where there's an underlying fundamental principle. We do something just because of the way that numbers work together. But PEMDAS is not that way. There's really no reason that you have to multiply before you add or subtract. Based on the story, though, we wanted to do the multiplication first. And that's the way it is with most stories. In most contexts, you want to multiply or divide before you add or subtract. So a long time ago, mathematicians just decided that that's the way we're going to do it. It's just the way we have chosen to do things. And I say we, not meaning that I had anything to do with it. It happened a long time before I had anything to do with math. But we live with that, and it actually works out really well. Like I say, most of the time in a formula, you want to multiply or divide before you add or subtract. So using that convention really helps us out a lot. A lot of people try to make things easier in their lives. They want to go left to right because that's what they're doing in reading class, in English class. But really, it would make a lot more work if we did that. So we go multiplication and division first, addition and subtraction, and usually that's what we want to do in the context of a story. There are times, however, when we need to do the addition first, and that's what parentheses are for. And that was really what I was trying to get at. Not that there was anything wrong with anything that anybody said. I liked what everybody said And it's really more important for you to talk about your thinking about the question. I just wanted to let you know what my thoughts on the order of operations are. Something we have to remember, but we don't really need to put much thought into why. It just works out better to do it the way it's been done uh, for much longer than I've been doing math. Thank you for watching our video today. Hopefully I answered your questions. If you have any more questions, please email me. Um, I am used to having some really good discussions, and it's hard to do that one little piece of the discussion at a time. If somebody would like to have a WebEx session sometime, I do have the capability to do that. So if you want to have some more immediate interaction, we can try and set up a time to do that. Email me and let me know. Thanks for watching.